Alrighty, good morning, guys. So welcome back from break. So I'm just gonna go over a couple dimensional analysis problems on your assignment, just to help you guys out and to refresh your memory for today. And so just make sure that you guys are following along. I'm basically giving you the answers to your assignment today, which should look like this. Okay, so let's actually get started with one that's pretty simple. Let's get started with number 1. Okay. So like we said last time, before we went off for break, we always want to write down our starting number. So our starting number here, if we just take a look at this problem, if you run a 5 kilometer race, how many miles will you run? Okay, our starting number is 5 kilometers. This is what we're starting off with. We're starting with 5 kilometers. Now, what we want to do is we want to set up a fraction so that we can get rid of kilometers, and we want to figure out what we're trying to get the number to. So it says, if you run a 5 kilometer race, how many miles will you run? So what we're trying to do in this problem is go from kilometers to miles. Okay, so what we did was we set up a fraction. And so since we want to get rid of kilometers, we're going to put it on the bottom. Okay, kilometers on the bottom. And we want to turn that into miles. So what we're going to do is we're going to put miles on the top. Okay, now if you guys remember, when we have a fraction like this, the top and bottom have to be equal to one another. So what we're going to do is we're going to take a look at this chart right here. I have a copy on the side if you guys want to look on the side, but there's one at the top of your assignment. And we're going to look for an equation where we have miles and kilometers. So if we take a look up at the table, you should see that we have an equation where 1 kilometer is equal to 0.621 miles. So this is the equation that we're going to be using, the one that I have boxed right here. All right, so since we have kilometers on miles and the same fraction, we want to make sure they're equal to one another. So we're going to use this equation. So if we look up here, what number is next to kilometers? Okay, you should see that it's the number 1. So we're going to put the number 1 next to kilometers on our fraction. And then next to miles, we have 0.621, right? And we put it next to miles. And the reason why we do all that is because we want the top and bottom of the fraction to be equal to one another. And now what can happen is we can cancel out the kilometers, because if you have something on the top and bottom of a fraction, they cancel each other out. And we just need to plug this into our calculator. We know we did it correctly because the only thing I have left is miles. All right, so I'm going to pull up my calculator. And if you pull up your calculator, all you're going to do is the top numbers divided by the bottom number, multiply the tops, divide the bottoms. So 5 times 0.621. And if we divide by 1, it's the same number. So our final answer right here is 3.105 miles. Okay, so 5 kilometers is equal to 3.105 miles. All righty. So not too bad, pretty simple. All we need to do is write the numbers that we want. Our starting number, get rid of the units by setting a fraction, and then just keep using these equations until we get the answer that the question is asking us for. All right, so let's do one more, and then I'll have you guys try the rest on your own. Okay, so if we scroll down a little bit, we'll try one that's a little bit harder. All right, we'll try this one right here. A car is traveling at 72.4 miles per hour. Now, this is one that we looked at last time before we went on break, and our starting number is 72.4 miles per hour. Now, if you guys remember, this word per means equals 1. So what this problem is telling us is that our starting number is 72.4 miles equals 1 hour. And the question is asking us to find the answer in meters per second, which means it's going to be meters divided by seconds. So our starting number here is going to be a fraction, because it's going to be 72.4 miles divided by 1 hour. Okay, and we want to turn that into meters per second. So what we have to do is we have to cancel out the miles and the hours like we did before and turn it into meters per second. Now, if you guys think you could try this on your own, I recommend pausing the video just to see if you could set it up, get some practice in, but it's all good. I know it's been a long break, so I'm gonna take it step by step for you guys. Okay, so what we're gonna do is we're gonna start by turning miles into meters, and then after that, we're going to turn hours into seconds, okay? So let's start by getting rid of the miles. So I'm going to set up a fraction, and I'm going to put miles on the bottom of the fraction. That way I can cancel out the miles. Now, if you take a look at this chart, we don't have an equation where we have miles equals meters. Okay, there's no miles equals meters. And so what we're gonna have to do is we're gonna have to turn miles into something else before we could turn it into meters. So if you guys notice here, we have 1 mile is, or 1 kilometer is equal to 0.621 miles. It's the same equation we used earlier. And so if we use this, we can turn miles into kilometers. And then after that, you're gonna notice right here, there's another equation where kilometers equals meters. So what we can do is we can turn miles into kilometers, and then we could turn it into meters. So that's kind of our roadmap. We're going to turn miles into kilometers, and then we're going to turn kilometers into meters. Okay, so for this fraction right here, we are going to be using this equation right here on the right. We're going to use 1 kilometer equals 0.621 miles. We're going to plug this into the fraction. Remember, the top and bottom of the fraction has to be equal. And so what we're going to do is we're going to put 0.621 miles on the bottom, and that's equal to 1 kilometer. And if I do that, I can cancel out the miles. Okay, now I have kilometers per hour. Okay, but I don't want kilometers, I want meters. And so we're going to use the second equation right here. We're going to use the second equation that states that 1 kilometer is equal to 1,000 meters. So what we're going to do is we're going to set up another fraction. And this time we're going to plug in the numbers from this second equation right here. I have kilometers on the top, and I want to get rid of kilometers. So I am going to put 1 kilometer on the bottom because that's what we have here. And that is equal to 1,000 meters. So we're going to put 1,000 meters on the top. The kilometers will cancel out. And now we have meters on the top, which is exactly what we want right here. So we're done with the meters. Now we just need to turn hours into seconds. Okay, so we're going to go to this table again and look for hours and turn it into seconds. Now, if you notice, you don't have an equation where it's hours equals seconds, but same thing as last time. We have an equation where we have hours equals minutes, and then we have one where minutes equals seconds. So what we're going to do is we're going to set up a fraction where we turn hours into minutes and then minutes into seconds. So we're going to set up a fraction. Now, if you notice, hours is on the bottom right here. So if I want to get rid of hours when it's on the bottom, we're going to have to put hours on the top because the top and bottom of the fraction cancel each other out. And so we're going to use this equation right here. 1 hour is equal to 60 minutes. So 1 hour is equal to 60 minutes. And if I do that, the hours on the bottom and the hours on the top will cancel out. And then last but not least, we're going to set up a fraction using this equation right here, where we're going to put minutes on the top because we have minutes on the bottom and we want to get rid of it. So minutes cancels out, and that's equal to 60 seconds. All right, so just to make sure that we did it correctly, let's look at our units. We wanted to make sure that meters was on the top and seconds was on the bottom. So if we take a look at all these fractions, we're going to see that we have meters on the top and we have seconds on the bottom, which is exactly what we want for our final answer. So we know we set everything up correctly. Okay, so our answer is going to be in meters per second. All right, now we just need to do our calculations. So same thing as before, multiply the tops, divide the bottoms. So the first number I have on top is 72.4 times 1, which is the next number on top, times 1,000 times 1 times 1. Okay, so you're just multiplying all the numbers on the top. And then you're going to divide by everything on the bottom. So the first number on the bottom is 1, so divide by 1. Divide by 0.621, divide by 1, divide by 60, divide by 60. And for our final answer, we are going to get a value of 32. I'm going to write it right here, 32.385. I want 3 numbers after the decimal point, and so there you go. Your final answer for this problem is going to be 32.385 meters per second. All right, so there you go, guys. Those are the answers to number 1 and number 6 on your assignment for today. So you only need to do 7 questions. Hopefully this was helpful. If you guys are still having trouble, you guys can go back and look at some of the older video lectures on dimensional analysis. I do have the answer key as well, so you guys can check that if you guys want to double check, make sure you got the correct answers. Other than that, guys, good luck on your assignment, and I'll see you guys next time.